All right, listening up. So, surface area. Can you write surface area at the title of your page, please? When we are looking at surface area, it is just another version of area, okay? Area is when we're looking at sort of 2D shapes, rectangles, things like that, okay? Surface area is if we're looking at a 3D shape. So, for example, a water bottle, okay? A 3D shape, and what is the area around that 3D shape? So what's the area around here? You need to go downstairs, sign in. The area on the top, the area on the bottom. Okay, so surface area is about the area around a 3D shape. Okay, now, so the area, surface area is the area of the outside of a 3D shape. Break down, and to do that, we need to break down the 3D shape into each of its 2D elements. So we need to work out what shapes are around that 3D shape. Now, today we're going to look at surface area of a prism. I'll just wait for you to write it down and I'll explain what a prism is. So a prism is describe it better. A prism is a 3D shape which has two base shapes of the same size connected by rectangles. So today we're looking at the surface area of a prism. Now I've written there base shapes, which is also like a cross section. I'll explain what that means in a second. So I couldn't find anything around the room which looked like a prism, except for that. So we're going to go with this as our prism to start with, okay? So let's try to see if I can find anything else. All right, so if we think about a prism means that there is two base shapes. So you have to have two of the same shape connected by rectangles, okay? Two of the same shape. That same shape can also be called the cross section of the shape. And what that means is if I chop the shape multiple times, when I open it up, it will be the same shape. That's a cross section, okay? So if we look at this, ignoring the feet, well, I can't take it. Yeah, I can, but I'm not going to. So if I look at this is a prism. What is the base shape? Circle, okay? Can you guys see how there is a circle here? And there is a circle here, okay? Two of the same base shapes. If you hold it like this, you can see two of the same base shapes connected by one big rectangle, okay? So this is a cylinder, but you can also call it like a circular prism. It has circles. I want you to call it a cylinder, but if you think about it, it has two circles connected. If I chop it anywhere along here, what shape are you going to see? The same circle. You're going to see that base shape, okay? So the base shape, I need to get used to the word base shape because we're going to use it for volume as well. The base shape of the circle, that is the cross section. It's connected by a rectangle. Everyone understand that? Any questions about what a prism is? All right, so if I then looked at something like this, is this a prism? Why not? Good. The base shapes are the same in terms of them being circles, but this bottom circle is smaller than the middle and smaller than the top. Smaller than the middle and then the top is smaller than that, okay? And so if I chop it at all different places, the circles will be all different sizes, so they don't have the same base shapes. Okay, it's still a 3D shape, but we can't work out the surface areas easily. Everyone understand that? The difference between them? Yeah. All right, so we're going to have a look at some different types of prisms. Now, I need to warn you, on your formula sheet, surface area, they don't give you these formulas, okay? So they don't give you the formulas for prisms because it's expected that you can work out how to find the base shapes and the rectangles, okay? I'm going to give you some formulas to use, which means in your exam when you're allowed notes, you could put those formulas on your notes if you wish to, but it's more about actually understanding what the shapes are and what the formula means. Okay, so in a test, you're more likely to actually just have to work it out yourself. So the goal of surface area is break it down. Break down each of the 3D shapes into its 2D elements, which is what we've just written there. So we're going to start with a rectangular prism. So could you just draw, there's two pictures. Draw one picture and then the other picture with the actual numbers in it. Why do you think it's called a rectangular prism? Because the base shapes are rectangles. Okay, so the name of the prism is always about its base shape. The thing about a rectangular prism is that the base shape could be any of the three different rectangles because whichever way you cut it will have the same. Now, from now on, whenever we have prisms, what you're going to have is you're going to have your base shape, which is the one I've highlighted, and the difference between the two base shapes we're going to call the height. And this is going to be quite a bit more challenging when we go to volume, but if you can always think about your shapes and your two base shapes and you're holding your prism between your two base shapes here and here, the height is the distance between the two base shapes for everything. Okay, so for this, if I'm holding the base of the shape on my hand, rectangular prism, this is on my hand, the height is the distance between them. Okay, so height is going to be used in all 3D shapes, and it's always the height from the base shape. If you were holding the base on the base, what's the height? And I'm going to use a capital H because when we get to like triangles and stuff, you've also got perpendicular height of the triangle. So you need to kind of know the difference. So the height of the prism. All right, so what shapes are there in a rectangular prism? There's rectangles. How many types of rectangles? There's 3 types. Okay, so if we look at that, the one which I've highlighted in yellow, there's one at the front and there's one at the back. If you look at the one on the top, there's one of them on the top and there's one on the bottom. And then there's one on the side and there's one on the other side. Okay, so if we look at this, if we look at our example one, what we need to do is we need to go, okay, so we've got one rectangle which is 1 metre by 4 metres. But we're going to have to then times it by 2 because there's 2 of them. Can everyone see that? Then we've got another rectangle. Now, I did warn you at the start, I'm really bad at drawing shapes. I'm sorry. You're just going to have to deal with it, which is 5 metres by 4 metres. And we're going to have to get 2 of them. And then the last one of those sides, which are 1 metre by 4 metres. And we're going to have to times that by 2. And we're going to need to add them all together. Does that make sense to everybody? So we've got 6 sides. So we have to find the 6 different rectangles. So if we use this in terms of L, W and H, this could actually be made into a formula. As I said, this formula is not on your formula sheet. But the way which we could do that is we're going 2 lots of length times width plus 2 lots of width times height plus 2 lots of length times height. That's going to find your TSA. What's TSA stand for? Total surface area. So you can either break it down into rectangles, draw out the rectangles, add them, or if you know what you're doing, it's easier to go 2 lots of, let's say the length is 1 2 lots of 1 times 4 plus 2 lots of 4 times height is 5 plus 2 lots of 1 times 5. That would be your working out, because you're saying 2 lots of the rectangle, which is 1 times 4, plus 2 lots of the rectangle, which is 4 times 5, plus 2 lots of the rectangle, which is 1 times 5. What measurements are going to be? No. Square meters, because it's still area. Okay? Already done that. Oh, that didn't work. Oh, what's happened? Can everybody see that? Is that okay? So anytime you get any sort of surface area, if you get stuck and don't know this sort of formula, just break it down into the shapes. You will get marks for each shape you get correct. So if you get stuck, break it down, get parts of it, even if you can't get the whole thing. Make sure at the end you write TSA equals and add them all together, because that's going to get you a mark, because at least you know that you need to add them all together. Any questions on rectangular prisms? All right, so what's a triangular prism going to look like? It's going to have a triangle, 3 rectangles, and a triangle at the end, and the triangles are going to be the same. The rectangles don't have to be the same, because it's going to depend on the sides of the triangle as to what they are, okay? So if we look at, oh, actually, I've gone to a cube. Why don't we go to a cube first, because it's already written there. If we look at a cube, what are the shapes in a cube? 6 squares. So the formula is just 6 times L squared, 6 lots of length times length. So for this one, our total surface area will be 6 times 2 squared, because one of those squares will be 2 times 2. So 6 of them is going to be 6 lots of 2 times 2. So 24 square meters. Done that one pretty quick. Does anyone have any questions? It's more about drawing them. There's a few different ways to draw them. If you're having trouble, try drawing a square and then go out diagonally and then fill up those spaces. Or the other way is to do 2 squares offset by each other and then fill in the spaces. Up to you. Some of you guys are really good at drawing cubes. I don't look notes. I want you to like fill up your page. Like, yes. You're not going to be able to find it. Georgia, can I do this for a second? Thank you. All right. Any questions about a cube? A cube is 6 squares, so they're all the same, 6 of them. Anyone still writing? All right, so now we'll go to the triangular one we've already talked about. So a triangular prism has a triangle at the front, a triangle at the back. What's the base shape? A triangle, okay? And it will have 3 rectangles joining them up. So where people have trouble with this, and could you make sure you draw this properly, is that we have a height of the prism, but we also have an H here. What's that stand for? It's the perpendicular height of the triangle. Because you have to find the area of the triangle, we need to sort of have a differentiating factor between them. So I've just used a lowercase h versus an uppercase h, but you need to know the perpendicular height of the triangle to be able to work out the area of the triangle. So I've got base and height still, so you can still find the base and the height for the area of the triangle, but we also need to know x and y to work it out as well. Often, given that we've done Pythagoras, they might also get you to use your height and maybe half the distance or something like that to find one of those slant lengths as well. So it's expected that you're always using Pythagoras in these sort of questions. There's a reason why we did Pythagoras first. So anytime you look at a triangle and you go, I don't know one of the lengths, always go, could I use, is it a right angle triangle? Could I use Pythagoras to find one? Yeah? All right, so how would I find the area of this? 2 lots of the triangle, so 2 lots of half base times height plus h times y, because we've got that rectangle, plus h times x, because you've got that triangle, plus h times b, because you've got the bottom rectangle, okay? Rectangle, rectangle, rectangle. Okay, so in essence, our formula would be, now why have I just gone BH here? Yeah, but to find a triangle, it's half base times height. Because we've got 2 triangles, 2 lots of half equal a whole, okay? So you can just go base times height, which is your 2 triangles, plus x times h, which is one of your rectangles, plus y times h, which is one of your other rectangles, plus b times h, which is that base triangle. I keep saying triangle, rectangle, sorry. Rectangle, rectangle, rectangle. I drew a rectangle at least. Any questions? All right, so for this one with the picture, base times height, which one's base and which one's height? 6 times 4 plus 5 times 11 plus 5 times 11, or you could have done 2 lots of 5 times 11. Because of those dashes, they're actually the same rectangle, and the base would be 6 times 11. Now, if you wanted to, you could just add them all together and go 16 times 11 if you wish to, because they're all times 11s. So we've got 24 plus square meters. Any questions to there? We okay with those shapes? All right, there's one other type of cylinder. I'm just going to move into a different page because I'm changing. I'm going to do that. Has everyone written that down? All right, so let's look at a cylinder. Actually, before we go to a cylinder, let's actually think about a cylinder. All right, so your next one's a cylinder. The cylinder looks like this. We've already said that there's a circle, another circle, and a rectangle, yeah? All right, so how would we find the surface area of this? What have we got to find first? The circle, okay? So how do we find the area of a circle? We'll look at that one next time. pi r squared, okay? So we've got to find pi r squared here and pi r squared here, so 2 lots of pi r squared. Then we've got to find this rectangle. Now that's the challenging bit, because if we have a look at a piece of paper, all right, and we put it into a cylinder. Sorry, the folder, it's not a very good cylinder. If you have a piece of paper and we put it into a cylinder, notice that the rectangle gets made into a cylinder, yeah? All right, so if we put the base shape on our hands, like I've asked you to, where's the height? This distance here, okay? So this side here is the height, okay? It's also one of the lengths of the rectangle, isn't it? Okay, so we already know whatever the height of this shape is one of the sides of the rectangle. Now, the other part of the rectangle is, if we look at the top, is this part here. How do we work out, how can we work out, if I don't tell you what it is, how do we work out what that is? Yeah? Say again? No. The perimeter of the circle, what's the word for that? That's right. The circumference, okay? So the circumference of the circle is one of the lengths of the rectangle. So we've got to find the circumference of the circle times by the height. All right? How do we find the circumference of the circle? 2 pi r, or pi times the diameter. But given that we're using the radius for the area, 2 pi r is probably the easiest one, because we don't have to use the same variable for each of them. Okay? Does everybody understand that? Can we all see why the circumference of the circle is the distance of one of the ends of the rectangle? That's the main bit I need to make sure you understand. Now, just be aware, sometimes you might get asked to find the surface area of an open cylinder. What does an open cylinder mean? No bases at all. Okay, so if it says open, it pretty much just means that. Okay, so you've just got to find the rectangle. Okay, it might say a can with a lid with no lid, and that would mean you'd have the base and the rectangle. Or it might say a closed cylinder, and a closed cylinder would be this whole shape. Okay, so you need to be aware of either the story, which you've been told, so a can with no lid, you have to have a base. Okay, if it says like a tunnel, no bases at all, no base and no lid. Okay, so it was just looking at like a cement tunnel or something like that. So you've got to think about the story to work out what formula to use. Because where most people go wrong with cylinders is that they just assume, they look at the formula on the formula sheet and they go, yep, easy as, rectangle, 2 bases, done, but they haven't actually looked at the story. So the most important thing is to think about whatever you're asked to do. Right? So, cylinder. So we've got 2 lots of the circles, and we've got 1 rectangle, which is the height, and 2 pi r, which is that circumference we just talked about. So if it's a closed cylinder, then you're looking at 2 times pi r squared, which is your 2 circles, plus 2 times pi r h, because we're saying the circumference times by the height. If it's completely open, we only have to find the 2 pi r h, because we don't have to add the circles. What if it had a base but no lid? You'd have to add 1 lot of pi r squared. So open means no, neither, okay? Closed means both. And then think about the story as well. If the story says open but it talks about a base, you need to be aware of if it tells you there's a base, there's definitely a base, okay? Which one? 2 pi r, because it's the circumference. if you're having trouble with understanding that, please let me know. All right, so this says, and this is our last one for today, find the total surface area of the closed cylinder. So closed cylinder means 2 circles and the rectangle, okay? So could you guys try and do that for me, please? I've just stolen your book. All right, so for the total surface area, we need to say 2 times pi times r, which is 4 squared. That's your 2 circles. Plus 2 times pi times 4 times 10. And that's your rectangle. Someone got an answer? You got an answer? Still loading. Still loading? Say it again, sorry? 351.858. So what would we round it to decimal places? 858.86. Don't round to the nearest unit, round to 2 decimal places. Meters, square meters. Any questions to there? All right, your homework, we've got into chapter 9, so exercise 9A. Questions. Now, be aware, questions 6, 7 and 8 say a trapezoidal prism and a hexagonal prism and a pentagonal prism, okay? Now, we haven't done hexagons. However, from yesterday in the chapel, you can work out that a hexagon breaks down into 2 trapeziums, okay? So you can work out what the area is of that shape. A pentagon would break down into a trapezium and a triangle. So it's kind of putting everything together. So questions, you've got quite a bit of time in class now to do. So questions 1 to 8 and question 11. 1 to 8 and question 11. Don't worry about 9 and 10, we'll be doing them another time. Okay, they're all prisms.